I can just confirm that building is more than consuming. I would encourage everyone to look on it as I use the technology for my own unique creativity or processes. That's the positive thing compared to having fear of some AI takes over. I don't believe this at all.
Welcome to a brand new episode of our podcast, Human and AI, Minds, Machine, and a Gradient Descent.
Thanks for tuning in to our geeky podcast, where we discuss the fascinating field of AI and machine learning, corporate craziness, passion for technology, and the role of humans. We are your hosts, Uli and Abri, and we're happy to have you with us today.
You know what, Ari? Let's talk not about the boring AI stuff, right? Large language models.
Yeah, that's so boring.
Oh, that's so boring. It's so yesterday, is it? So yesterday. You know what is today? What is tomorrow, actually? Physical AI. I guess, let's talk about profoundly something physical, right? Or let's say physics AI seem to be in every world, every buzz nowadays. Everybody's talking about this. What does it actually mean, right? What does it mean? Physics drives our car, our planes, our trains, the products actually every day we're using here, right? And so let's talk about the role of physics. Is it, AI that understands the dynamics of physics? Is it physics AI in terms of this is the embodiment? Is it robotics? Is it human? I guess we need to have a cool guest, right? About talking about these aspects. So how to cope with things that not yet are built, but need to be able to be built, right? Is there a technology that helps us with this?
Uli, so many questions.
Yeah.
But I'm happy. I'm sure we'll have just the right person to help us unpack this. And actually, if we look at the market and some numbers, we can see that the market for simulation software is already a multi-billion-dollar industry as well, and is also projected to nearly double in the next decade, quietly powering the next wave of industrial innovation. So we are really like bridging physics, AI, and simulation here.
And I would say also we bridge somehow two really cool things, which is, a bit of the science of data and actually the science of rockets, right? And about, utilizing this predictive capability, this power of AI at the very core of physics and engineering, right? And maybe doing things we even can't imagine.
And Uli, you already alluded to it. We've got just the right person here with us today to help us unpack some of these questions, some of these aspects, and shed some light to the dark. We're so happy to be joined by Moritz Frenzel, Global Technical Director for Engineering, Data Science, Auto at Altair. And Moritz is a true innovator. He's a status quo challenger who champions creativity and teamwork, and he loves to bring people together and technology. So Moritz, welcome to the show.
Thanks, Aubrey. Thanks, Uli. Great pleasure to have you here and have this conversation. As you started with a lot of questions, I'm curious how we get going here.
Yeah, Moritz, it's super cool to have you, right? And we're all excited, right? We're all pumped up, actually, talking a bit with you. Because you're dealing with quite some interesting aspects between, engineering and AI. You have some experience, I guess, in the mobility. So let's look forward, right? This is what we do in our tech space. Let's look forward.
Shaping narratives,
Shaping narratives for sure. But with the tons of experience that you have, right? Let's imagine 2035. It's now 2025, those who's, it's so 10 years. That's a huge gap, actually, right? So 2035, what's one groundbreaking feature of technology you love to see in engineering, right? That could be the game changer, as we say, right, in corporate sometimes.
10 years. So engineering is fast and slow. Mm-hmm. So if you look on cars, airplanes, infrastructure, let's start slow. I mean, we would desperately wait for year-wise update of our infrastructure, but obviously engineering of bridges is not as fast as we wanted it. So no change in 10 years, maybe an update of the same bridge, maybe not. On the other hand, this digital aspect of things is so fascinating fast. So the speed is just amazing. Maybe that's what drives even more passion for this physical or engineering, creating things, building things. And there, a lot of things can happen in just 10 years. So the software, the algorithms are growing extremely. So if we take this car, I think, well, the standard OEMs have their plans already. So it'll be a car, maybe a very nice one. It'll have four wheels, and they engineered it to scale. But maybe there is someone with another creative idea I'm not aware of, and then this guy creates a mobility asset, a car with 5 wheels, where everyone knows 5 wheels are not going through right now, but then it's appealing, and then you have this, well, disruption, but someone has tried it out using some, like, all these digital assets. So that guy will not be a global shipping OEM. It will be something local, maybe with, fast, localized manufacturing, whatever is behind there. Question is this product then really appealing? Would it arrive with you? Or is this just another nice example of this one Ferrari 2.0, which someone likes, but no one else touches it? So that scaling across the world is still a challenge of engineering. So
that would mean you challenge actually aspects. So it's like, the natural answer would be in terms of, in 10 years we will have autonomous driving. Right. But you say like, maybe one thing, but maybe it's not the car. Maybe it's not the car as we envisioned. Maybe AI found different designs that makes the car totally repurposing its aspects, not only flying and stuff like that. So this is the thing. We need to break our steroids in terms of what do we actually imagine. Maybe we get hit by a totally different innovation from some random dude tackling with cool technology, some different angle to innovation. Cool.
And questioning this is always, if we call it a car, it's probably global OEMs and you buy it in that same shop but via website. But if it's a mobility asset which serves that same purpose, that is bound to be engineered by someone else.
Are you excited, Aubrey?
We not know this. And
I'm excited. So maybe it could be like the next car is, I don't know, an entertainment space where we can go across the world and watch movies and be in immersive spaces.
Or finally, the train is as comfortable as today your car is, and then you feel better in sitting in that same asset.
Yeah. Okay. And what would be your best guess if you were that guy to come up with a crazy idea? That's a tough one.
Yeah, that's a tough one. I think, again, it'll serve way diverse needs so that, individualization will scale further and further. And that's why it makes difficult to name it the global asset of a car or a train.
No, totally.
But the need will be served with different solutions.
That brings us already in a bit of the pillar of, in the role of creativity, right? And the role creativity plays in the age of AI, right? We see currently a lot of aspects with regards to generative AI, producing images, even the cool movies, I must admit, right? It's pretty cool to see, we're moving from a couple of seconds to actually maybe almost minutes, right, of movie sketch. So that somehow is it creativity? I'm not sure. Happy to hear your view, right? Is this a creative process? And the other one is about how does this new paradigm then fit to this actually engineering perspective where you arise? And it's like, form follows function, right? So are we finally having cool things that look cool, but also, functions cool? Is that the art of the impossible with AI and tech and simulation and stuff?
First, I'm a bit skeptical of maybe sitting here on that chair, because for me, creativity is more than creating. So creating a movie, creating a song, for me to have a relaxing evening is more of this pattern, like creating new things. It serves its purpose, but I would still say creativity is something way more complex. Maybe that thing which is still human. I mean, you can discuss with musicians and they still are out there, although AI can generate songs. So that's where I haven't seen any creativity from AI. But obviously the terms of generative AI and all this, the tools to craft will scale very, very fast. And that's also the heart of engineering, because I would believe engineering is way more connected to creativity than to physics, by the way. So, and therefore that'll scale a lot, and that's why I'm so fascinated of this whole field, right? What is tool and what is augmentation and what is lazy replacement of just another engineer, where we have so many millions of engineers out there. Maybe they can then focus on something, or don't even become an engineer, because it's just creating another car which drives from A to B and does the job. That's repetitive crafting.
That's execution. And what you're referring to is like that stage before that, like what are we even building? And then maybe also to link it back to our first question, where we thought about, okay, what is that new vehicle of the future looking like? So how do we get to that stage, and how do we break out of those patterns? And like, how do you see that role of creativity being like these days in the age of AI? We can like build and execute so fast.
Invention or innovation, right? Yeah. These are also these two terms. I mean, invention is this creative element, and then innovation is bring it to scale, bring it to market. So one of my personal assets was to have a part which drives around in this BMWs out there and is a patent from mine. Okay, that's my personal footprint, but it was obviously innovation from the whole organization and not the invention from myself. So on the other hand, now, if people can invent in a democratized way and don't need this large organization to drive innovation, because it's serial production, it's globalized, and it's cost efficient, then we will see way more exploration and way more fascinating new engineered things due to the democratization of, innovation. Although the invention still comes from minds and humans. And then comes these, the subjective appealing aspects. Is something nice? Style. Is style design? Yes, it is. But is it engineering design? Also these English terms mix and match sometimes. And once it's subjective, then it's not a pattern anymore. And that's where I would say still core AI technology lives more from pattern and existing things, and not from.
Yeah, but I have to think. So we're working currently in a setup where we design certain kinds of chips with Gen AI, right? And so chip design, of transmissions and heating, and modulating the complexity space of how to design the best way. And it has 3,000 parameters, right? Which is crazy, and that's why these folks which are work there, it's like they come up with certain kind of templates and certain kinds of experience that they have, right? And then we thought, like, could it be that AI actually comes up with a cool design that makes also function of totally worth things? Yeah. And I somehow compared then to, I don't know, Netflix paradigm, right? Netflix recommends me, you have, 30,000 movies in Netflix. And it recommends me always 10 to 15 more I don't read probably, right? Or 20 is likes. And then I do the selection. It's like, actually pretty cool. And I like this kind of style. I like this kind of aspects. But the pre-selection, right? In terms of, I think the preferences, the recommendations, people like me look like that, my history looks like that, my knowledge about this is that, right? And this kinds of recommendation, I think these systems also in a simulated environment, synthetic data generated, or exploiting the space of design paradigms, right, gives already certain kinds of indications of, I think you have a preference, you as a person, right? A preference, even so the decision is with you, right? We are still human in the loop, or a human in leading the decision making, and so in a lot of processes, right, in the infrastructure. But I feel, I don't know, sometimes I like, it knows me very well, actually.
Definitely. And a chip, I'm sorry, I'm not the chip engineer, but chips sounds like performance. So whenever you want to have maximum performance, it's not about subjective style, it's about performance. Now, still engineering to performance is a challenge on its own. So here, computers have augmented us, and they will take more and more of these highly complex decision-making while productizing things. And that's just a great continuation of what computers help us, as now computers use more and more data, and so it's more data-driven.
I think if you have now a somehow a channel, right, which says like this is human in the lead, right, and this is AI in the lead, like a shift on the level of autonomy, right? Do you think that we are in the next 5 to 10 years we are able to move this right on the one side in terms of that we feel like okay, now the AI is in the lead and the human will take the let's say observation, rather the safeguard channeling, right? But you leave a system, multi-agent or agent, right, or whatever bus you take now, right? But do you have the feeling specifically in the science space, in the simulation space, this is a needed paradigm we need to embrace? This, moving up the autonomy ladder, let's say. Yeah.
There, I would say this is this disruption challenge.
Okay.
And it's so. I mean, I love changes, so I like to be part of the disruption, because that slide. The question is who drives the slider, and if like many people in an organization or even without an organization can drive the slider to design your bicycle, then you may like to do it, and then it comes whether you focus more on style or on performance, and then you can take the decision. But nowadays, engineering is still, let's say, driven by large organizations, because you cannot scale on your own to productize and ship and do it at cost. And these organizational elements will be disrupted because it doesn't require, or software and AI can augment this, and then you can do it on your own, and you don't need to go into the shop and have a global manufacturer do it for you. And that's where, it even inspires more engineers, because I still believe engineering as that part of bringing physics and creativity together grows on this. It's simply augmented, and that's what I'm so looking forward to.
It also drives the creative disruption or distraction, actually.
Yep.
So we mentioned in the introduction that you're coming from Altair, and that's super exciting. And I think a lot of people in our audience would also like to understand more about Altair and what makes them special and what we can maybe also learn from them. And now, just like with the beginning of this conversation, we can already see that you have that passion that also aligns a lot with the motto of Altair, which is when data science meets rocket science, incredible things happen. Could you maybe share how this philosophy actually drives Altair's commitment to really empowering engineers, and not to just consume AI and AI models, but maybe to really create and build and craft and things that we're discussing now in the beginning? And what does this actually mean for how you envision the future of engineering?
So first of all, thanks for bringing this the quote from Jim Scapper, because I like that quote very much, and it tells more than all the technology, because rocket science is that placeholder for high-class engineering, right? Everyone would take this. And then data science, before it was famous, it was there, in particular early like banking. It's the dusty statistics experts, but I mean, they make a lot of money. So the asset as such of data science has been there and has its value all the time. And it comes with computing, analysis, calculation. So the scale of computers helped this. And well, Altair was a combination of software to ease access to users. So in both things, you don't serve the result of a data analysis, but you just simply make it more appealing for more than the statistical experts being very unique. And the same was in the engineering side, where then the simulation comes into play, which was there like again since 40 years. So, and simulation was even earlier for building rockets. Altair's software element was to have a good access for many engineers to do things which were able before. So Altair hasn't invented the core algorithms, but brought algorithms to users.
So things that were reserved for others are now suddenly available to a lot of people.
Yes, and they scale at least into organizations, so that's already great. Now bringing these concepts together is, I think, exactly what the new I call it hype, or what the new world is, because data is so abundant that you eventually leverage more knowledge from data than from the simulation. Once it's a complicated physics simulation and you need expertise to set this up. So that's why this slider is exactly sitting also on this software tools Altair brings to market. And that's exactly what attracted me. So I was happy to join that company. I think as it is part of this engineering vision, where Siemens has such a powerful background, that's that nice thing which brought us together.
Maybe it's called when data engineering meets rocket engineering.
Exactly.
Yeah, somehow.
Yes, and
right?
if you want to build your rocket, then start doing it.
Yeah. So simulation in engineering, right? It's and we briefly touched already, right? It's so bringing in the predictive power and the exploitation, right? There's always this balancing out, right? In scaling out and the trade-off between speed and accuracy of this application, and then you have the other interface, which people are mostly confused because there's one that is saying like physics AI and please detangle it, and physics informed AI, right, into surrogate model and stuff like that. Can you just separate for our audience a bit of the two concepts? Is that okay?
If you allow, I make a controversial statement in the beginning. Where
we love that. We love controversial statements.
Bring it on.
Maybe physics is overestimated in engineering.
Okay.
So, engineering is scaling, rethinking, repeat things, and a bit of creativity. This is what engineering is all about. But physics lovers rarely become engineers because physics on its own are, you know it very well, very complex, and maybe it distracts from each other. So that's why the rare engineers close to both things are maybe the nerdy ones. Maybe I am a nerdy one because, yes, I studied quite a bit of these equations behind, but in essence, engineering is simply do it, build it, use it. And that's why now the same with AI, where is this famous intelligence behind. If I bring physics next to AI, it is a driver of fascination, but sometimes out of touch, out of reach. So someone else should detangle this. Now, Altair has a product which is called Physics AI, and that is, let's say, the element of bringing what has been there being physics-driven simulated, because we have the solvers built once where there is equations inside. And then if this input is used in an AI sense, making it repetitive, have some data, learn out of patterns, then you predict things instead of running another simulation. But is this like the new unique way of using physics for something? No, it's not. And that's where also physics informed AI, all this, I simply don't know whether this is maybe more an excuse of not embracing or allowing the sheer amount of data to scale and just live on existing things and copy and paste. If copy and paste serves what you need, just use it and don't care whether it's like physics will tell you whether this beam breaks, yes or no, but it hasn't broken before, so it's probably a good beam.
Maybe this is not new to you, but obviously for many customers, it's new, right? So a technical system that understands where you can model the dynamics of physics behavior, right? I don't know, like wind and pressure and friction and these kinds of things, right? Is something, I guess, which is for many companies untapped potential, I would say, right? Because they never did it. I don't know how to do it. And seem to be the technology now gives, and for many years for you, right, since ages, like, what are you talking? I'm doing this since many moons, right? But for most of in the industry segments, it's not the case, right? It's like, okay, I still have to question, how do I model my stuff? How do I bring the physical dynamics actually into a digital representation so I can tweak and test and what if and these kinds of things, right?
Yep.
So is this part of an accessibility? Is this part of has this leaped in terms of that, suddenly we get this tool stack, pretty cool, now I can do it. What happened the last, I don't know, 5 years? Why is it now possible?
Yeah. And the question is like, who's asking? Because do you want to simulate the bicycle? Take again this example. Mm-hmm. You're riding. Do you like the physics behind? Yes or no? That's to me still a subjective question. Mm-hmm. But yes, meanwhile the concepts of physics in the computer are they're in games. So if you watch movies, then they use physics to make it more realistic. So obviously physics is great. It's a great asset to have. And if physics being only for nerds now becomes accessible for everyone, because we simulate things, which means bring realistic physics into a digital asset, let's do it. And let's have access for everyone. And yet these advanced simulation, as you describe it, were also within engineering often bottlenecked. Mm-hmm. So if this goes at scale, then whether it's via simulation or data, it doesn't matter.
What were the bottlenecks which are now relieved?
Yes, the combination of the experts understanding the basic physics, then maybe accessibility to software. So UI is an important concept. Mm-hmm. Then the collaborative aspect, no one does things on its own, so you need interfaces. Mm-hmm. Meanwhile, it scales, and then like we tear down interfaces. There's not the one department owning aerodynamics. Everyone wants to have some aerodynamics in his design. That's what changes a lot.
So that means companies in the movement embracing more digital technology upgraded knowledge. So competence went in these companies in there. Second aspect, the user interface of a very MATLAB crazy geeky things meet it up and say like, okay, I can use it actually. Compute, I guess, right? It's complicated, heavy compute. So we have now this compute acceleration, also to the thanks of, machine learning, stuff like that. And then you can see that this is cross-functional across more department level. So that's an interesting aspect.
Yes. Yeah. So all of this, and the compute power was there, so that's for sure a given. I would maybe add the appealing element of things, right? Because physics is also physical, so we see it. It's a 3D object. Now, if your decision-making process is visually appealing because you still see the airplane, you see maybe bending or airflow, or make even electromagnetics visible, that gives you more confidence in taking decisions. And that's why the thing scales, and you don't go to the one expert in your company and ask him, is it correct, yes or no? But you take the decision more on your own, and that scales responsibility.
I have 2 daughters, right? Young kids? No, actually, no, not young kids. Sorry, Korea. They kick my ass now, right? No, they are not young. You're grown up, all good. So I found it fascinating the last year. So they embraced AI in terms of ChatGPT, as most kids, right? School and stuff like that. Is there a hope that they will embrace simulation at scale soon? Is it on that kind of democratized that everyday people which are not technique will say like, hey, I'm building a small simulation of this scenario, right? And with the recommendation of this is the good thing. Will simulation technology, will that kind of democratize and accessible? Do you foresee that, or will it remain for the next 5 to 10 years still a very nichey thing?
I have no fear for your daughters. Okay. My fear is for the grown-up engineers. Hear that? Because kids or grown-up, it's the same with mine. They're anyways curious, so they pick what they want, and they like to have more physics behind the scenes. And they even have to learn physics. So if this is appealing and they use today's tools for this, they would pick it up. Okay. Challenge is more on transforming existing engineering organizations and still the concept of please design and engineer for maybe durability of 100 years, that's where it becomes challenging, because that's maybe what your daughters don't foresee, and that's where expertise from engineering should still be in place. Although it looks nice in the computer, hopefully it is nice in the physical world as well.
Yeah.
So you're saying that actually like on the one hand, like that human agency is being like driven, like because now everyone has access and maybe one day everyone like simulates their own stuff. But then on the other hand, it might also be like a people challenge, that people that have been in a space for long and they've like done things in a certain way, that it might be especially hard for them to adapt to like those new tools, although they're there and very effective.
Yeah.
Okay.
And that's, I mean, going back to school, I mean, Newton's law of an apple falling is this now, do I need the equation or just need to have in my Google eyes or Google goggles, the ball falling exactly to the right position? And that's now where, learning and all this new ways of perceiving things is in your minds as well.
And growth mindset, as we say at Siemens, and we'll get to that in a minute. But maybe like to stay in the space of like new things arising, and we've seen AI making quite some strides when it comes to understanding text and images. But what if LLMs could also understand 3D geometry, and would like sky be the limit? How could that really transform engineering and design? Can you maybe elaborate on that? And I also heard something about a dishwasher.
I would allow to say geometry is the intersection of style, appeal, and performance. So
style, appeal, and performance.
Geometry is what you like,
love it. Yeah.
Form follows functions.
Uli will get a t-shirt now.
Got it.
So, but then understanding all aspects of geometry is just as ambitious as understanding all physics. So, I mean, there's a lot of math behind, and I don't go deep into this, but it touches your daily problems. So if you want to combine geometry with performance, then it's mastery. Mm-hmm. Do you need mastery for your daily dishwasher problem?
What is the daily dishwasher problem?
So my ambition is actually to fill the dishwasher to have maximum performance of cleaning. So understanding geometry or different objects and how the water cleans this is, I like to do this on a daily basis. Mm-hmm. But I wouldn't force others to do it. Sometimes it's just fill it in and get out and maybe measure the energy it takes. But why the heck should I understand the geometry pieces I'm filling in the dishwasher? Mm. So that's where such an example of how do people work with geometry is different, and which geometry drives their performance KPIs is also very, very subjective. Some people do the dishwasher this way and some the other way. Some follow patterns. Pattern is trainable to AI. Mm-hmm. Mm. But some may, like to have the physical cleaning in their head when they place it that way or the other way. And like the openness of the cup is downwards, yes, better, instead of upwards.
For me, it's a trade-off between, cleanness, noise, speed, and water consumption, right? And I think that's hopefully a simulation can build. I have only one button there, to be frank, where it's called start. Yeah. Right, but maybe I can have a twiggle and say now go for speed, now go for energy consumption, and now go things, and it simulates my stuff real time on live and based on my preferences. And
wouldn't that depend on what you put in the dishwasher? So
because that's the point, right?
Subjective.
Because nowadays you have those other like programs, right, Uli? Your dishwasher has that too.
Yeah, so if we talk a bit once again on the simulation, right? There's quite a picture, and we said there's a balance between maybe sustainability aspects and the diffusion that there is technology push. Then we see quite some aspects in terms of photorealistic stuff comes into the play, right? It's like, I guess, realistic rendering. I'm not sure, the combination of this. So how do you see the trade-off between, realistic worlds being built in AI and simulation and business reality, let's say, right? Can you resonate on this?
So I would say, like, coming from the business side of things, simulation is just better decision taking, right? You explore, you build scenarios, and that's what helps you to take the real decision with less risk, right? Now, if that, as you mentioned, and also my field, if that goes to physical objects and physical requirements, then it gets more complicated, and still decision making is the process side of it. So do I prepare the stuff for others to take the decision? And that's where these fancy animations from other companies come in. And I had the same, like, a lot of this was my life in a former company. You know, you prepare the material for others to take the decision. Now, if you augment this with appealing visualization, it helps the decision maker to take it. But still the question is, who wants to take decisions? We could also argue that if at your hand you can build the scenarios and you can explore, then you could take the decision already on your own. Why did you need to go to someone else to take a decision? Because, like, the better design compared to the worst design on your energy consumption, you have your target, you can take the decision on your own.
Moritz, we touched upon that people aspect earlier, and I wanted to pivot back to that. And it's quite interesting now. Like, Altair was acquired by Siemens, and Altair has about 3,000 people. We at Siemens are about 300,000 people. How do you see these cultures coming together? Like, for one, what could be emerge from that? And then that other thing, and that was what you alluded to earlier, there are also a lot of personal challenges now with the rise of technology and new tools, and also democratized access to a lot of tools. But at the same time, I still have to expose myself to that and be open to that and embrace that. And maybe that's also something that we could, at Siemens as the giant, could learn from more of a company like Altair. Or so what's your take on that? So
first of all, my personal learning, right?
Yeah.
Because I've grown up in Munich. I'm a German engineer.
Yeah. High quality, they're good.
That was your judgment. I left some high-class German engineering companies to follow this Altair US software company on that size you just described. It's not a startup anymore, but it was way smaller than now our nice Siemens company or family is. So the simple argument, smaller organizations act faster compared to large organization may hold. Now, you touched on the cultural aspect. Culture is not a number, right? Culture are other differences. So what is the Siemens culture? What has been the Altair culture? Do we fit together? I think we do. Altair had this only forward. Now we're forward together. That is still upcoming, and I like to even bring this little bit of Altair experience from these 2.5 years into the larger Siemens organization to maybe push here and there and be faster, not going back into this was the large organization, it defines where we go, and I fill in, because that was maybe part of the reason I've left other companies. So that's my own learning. That's my situation right now while being integrated. Let's see how we execute on this now being part together. I'm looking forward to this.
And we are
exercise.
certainly too.
For sure. And let's look even further. Let's look in 2035 once again, right? Closing the loop.
Only that's your year.
So this when we recorded with Richard Zocher, back in the days aspects, and he was resonating. It's like, hey guys, you need to accept that in the future you will be a manager of AIs, right? And I think it resonated as a bold statement, a good tagline. I have the feeling, right? Yeah, maybe. And it resonated with quite some folks actually, also in Siemens, and about these aspects and what does it mean. And so if you resonate with this tagline a bit, right? What does it do for engineering? You know what I mean? Are we now the conductor of little AI powered engineer agents, let's say, with software capabilities and on the, I don't know, APIs or MCPs or agent to agent, whatever frameworks, right, around it. Do we see that as we can package certain kinds of skills, and we need to, as engineers, learn to, how do we cope that? Do we need to accept that there are agents there?
Clear, yes.
All right.
Where's the problem with this? Because
why are you asking me?
What the heck are you asking? Yes. I mean, okay.
we had it with computers as well.
Yeah.
I mean, I still people told me that engineering has been done before computers. Okay. That's not my personal story, but yes, I already had the challenges of, well, use a computer for this and don't draw it with hand. Oh, well, but some calculation, you should do it with hand. Yeah, maybe you should or not. But I'm on the computer side. I love computers because they're
who doesn't, right?
Such a nice tool. So taking out trial and error of expensive hardware testing, who would not love this trajectory? So now mastering algorithms doing things on their own, who would not embrace this? So I simply would say engineers are exactly the right drivers for this, and they should build their tools or use the tools to build. Both things have its value.
That's a very positive message, is it?
Yeah, and maybe to add to that, so this is, I guess, already a piece of advice that you're sharing here, that they should go out there and build their own stuff and use it and embrace it, and there's no questions asked, right? But is there anything else that you would like to leave as a message, maybe to the audience that is listening in today? What is another piece of advice that you'd like to share? Or
so I can just confirm that building is more than consuming. So we sometimes see AI as coming out of space and we use it. That's how we use ChatGPT, large language models.
Yeah.
I would encourage everyone to look on it as I use the technology for my own unique creativity or processes. And that's, I think, no news for engineers. But that could scale to everyone, and therefore, yes, that's the positive thing compared to having fear of some AI takes over. I don't believe this at all.
So how can we shape the world? How can we build something and not what is AI going to do to us?
Yes, because we at Siemens, we are a technology company, so we will shape and build technology. We've done this, and we will do this in the digital time as well.
Oh yeah, here we go. Yeah. This is the way to go.
We've done always an interesting game actually at the end of our podcast, right? Is it?
Have we?
Have we? Right?
Have we?
We're prior Siemens GPT and prior GPT. I'm so used to GPT and Siemens GPT. It's our Siemens
props
platform
out there
for GPT.
to our IT team.
Yeah, really props. # you're awesome. Right.
Yeah, we have so our final game, Moritz, the time was flying. It's called Authentic Autocomplete. And we would like to wrap it up and play this signature game. And we'll throw out some sentence starters, and we'd love for you to complete them. Are you ready for the final challenge of 2025 of this day? So, starting off with physics AI is...
A rapidly growing software product from Altair, now Siemens.
Oh, see that?
That was the marketing answer.
We're not product spoiler here, right? We try to prevent it, but maybe it's a go. Okay. Simulation is
a great way to explore and drive decision making, and I'm happy if it is digital.
All right.
Okay. Technology with purpose is
a great claim for leading enterprises.
Ooh. Let that think. Easy one, last one. If I could invent one rule for everyone to follow in the world, it would be?
Stay curious. And if you my personal motto would be more like this quote from Abraham Lincoln. So if I had 6 hours to chop down a tree, I'd spend the first 4 of them shaping the axe. So still, think about what you want to achieve and not take the easiest way.
I just thought about what I want to achieve, and I hope guys out there in the market, right, and on LinkedIn and on Spotify, Amazon, Apple Music, and all the platforms that you listen in there. I hope you had a great experience talking about with Moritz as a fantastic guest and Aubrey as my trusted partner in crime and co-host podcast chief boss, and on this insights on the Human AI podcast. Moritz, thanks so much for, spending time with us, recording a cool session in downtown in Munich, downtown in the Siemens AI Lab. Thanks for being part of the game here.
It was a great pleasure and hope to do this again.
And folks out there, stay tuned, stay humble, stay bold, stay committed, stay open-minded, and hear us at the next Siemens AI podcast. Cheers.